Hello everyone. Today we are going to discuss the operation of DFIG, doubly fed induction generator. So doubly fed induction generator, why it is used in this scenario? DFIG is able to produce fixed frequency output voltages, and this output voltage is again fed to the AC network. As you all know that generator operation is to convert mechanical energy input to the output voltage. So this generator is used in uh, feeding the output voltage to the AC transmission lines. So one of the major problem with singly fed induction generator is that singly phase induction generator has the problem of variable frequency is variable on the output voltage. So we don't want the frequency to be variable in the output voltage for AC networks. To overcome this problem, we are using doubly phase induction generator, which has the advantage that its output frequency is not variable. We all know that how the induction generator works. Induction generator works, it is the reverse process of induction motor. So induction motor, how induction motor is working, we are supplying we are supplying the input voltage to the stator field, and the output rotor rotates, generating the mechanical power. Here the rotor is acting as input, mechanical input. Rotor is rotating and the output is generating voltage, AC voltage, which is supplying to the AC network. So as I discussed in this lecture that singly fed induction generator has the problem of variable frequency. So let us see how the expression comes out to be. This is the expression for frequency of output frequency at stator. Output frequency of AC voltage induces across the stator. So output voltage, we all know that output voltage is feeding to the AC network. But how this output frequency is varying, this is depending on this equation. So here small n is nothing but it is the speed of the W phase induction generator rotor, and n is the number of poles of DFIG. So this equation is similar to, as we know all, that this equation is similar to what we know, n is equal to 120 f upon p, synchronous speed. This formula is similar to that. Here the frequency is determined by using this formula. So this is all about stator frequency equation for singly phase induction generator. Let us see how it can be modified for DFIG. In equation 3, it is possible to determine when the speed of the rotor is equal to generator speed. The frequency of the AC voltage induces across the stator winding is equal to the frequency of the AC power network. So this is one of the important thing. The frequency of the AC power network, here it is same as the frequency of AC voltage induced across the stator winding. So if this frequency is varying, then this frequency will also change. To keep this frequency constant, we have to use the AC induction doubly fed induction generator. So the principle of operation is same in DFIG and SFIG. The only difference is that the magnetic field created by the magnetic field the magnetic field created by the rotor is not static, but it rotates at synchronous speed of the rotor. Speed is proportional to the frequency of the AC currents fed into the generator rotor. We all know that the formula of rotor frequency AC current is slip times of frequency. So DFIG, there is one additional term comes here, is the frequency of AC currents. So this frequency of AC current is in addition to the stator frequency terms earlier we discussed in SFIG. For example, this is the formula for SFIG. This is the frequency formula for SFIG. And in addition to this, if we are having frequency of AC currents in addition to this, then the formula of frequency in this becomes the formula for DFIG, frequency of DFIG. Let us see how it works. The now we all know that the formula is changing, so taking into the account of operation of DFIG, it can be determined that when the magnetic field of the at the rotor rotates in the same direction of the generator, and when it is rotating in against the direction. So when both are rotating in the same direction, the rotor speed and rotor speed speed of the rotating magnetic field adds up. They both add up. So if both are rotating, if both are rotating in the same direction, then the both frequencies, the rotor speed and the speed of the rotating magnetic field, or we can say rotating field of the AC currents, they both are adding up, this giving the stator frequency output. So if, however, if they both are not running in the same direction, they will subtract from each other. So now let us see how it works. Here we are having the diagram showing the stator frame and the rotor mating field. So we can directly see from here, if the both rotor speed frequency and the rotating magnetic field frequency is same, then they both will add. However, if they both are rotating in a different direction, then they will subtract from each other. We can directly see from this formula, this diagram also. So in other words, frequency of the stator AC voltages produced at the stator is proportional to the speed of the rotating magnetic field, and it is adding to the frequency produced by the rotor. So the speed of the stator rotating magnetic field depends on two terms. One is rotor speed and the other one is frequency of the AC currents. They both are playing critical role. So using doubly fed induction generator, how the frequency remains constant? The primary reason for using DFIG is generally to produce a three-phase voltage whose frequency is constant. So let us see how it works. If there is any to achieve uh, frequency constant, if the frequency of the AC currents fed into the rotor winding generates continuously adjusted to counteract any variation in the rotor speed. So by varying the frequency of the AC currents, frequency of the AC currents, we can counteract any change in the rotor speed. Therefore, the frequency of the output voltage remains constant. So this is all which is playing a critical role in this reference frame. The frequency is, for example, let us see how the fluctuation can be met. For example, the frequency of AC currents that need to be fed into doubly fed induction generator winding to maintain the generator output same as the value of the AC frequency network. The AC power depends on the rotor speed. So this is the final equation we are having. This is the final equation, and if there is any change in this frequency, for example, we have to make this constant, it has to be fixed, and if there is any change in this value, then this value also changes. So these two values counteract so that F network remains fixed. This can be explained This can be explained, for example, if the generator rotates at nominal speed, the frequency of the rotor, if the generator rotates at nominal speed, that is synchronous speed, frequency of the rotor AC currents need to be fed into generator is 0 Hz. That means there is no need for additional changes in the frequency of AC current. But if when the frequency of the rotor speed decreases below the nominal speed, synchronous speed, then frequency of the AC currents that need to be fed into the generator increases accordingly and in is of the opposite positive polarity. So let us see, for example, considering this with the help of an example. Mm, Let us have DFIG having the four matic poles. Generator supplies power to 60 Hz AC network, and an external source makes the generator rotate at speed 1980. And now the frequency of AC currents needed uh, to be fed into generator so that the frequency remains fixed to the 60 Hz. So this term has to be adjusted, and this term comes out to be after the difference is minus 6 Hz. So this means the rotor frequency has to be adjusted to 6 Hz so that the final output frequency remains 60 Hz and the rotor speed rotate at synchronous speed. So this is how the DFIG works. So this is all about DFIG operation, and this helps in working of the windmills, wind turbines, because there the frequency is varying with respect to the operation, and in that case it is very much necessary to have fixed frequency in the output so that the voltage is feeding to the voltage that is fed to the AC network should have constant frequency, and in that case DFIG plays a very important role. So this is all about the today's lecture. Thank you very much.